Welcome to our course, Data Science Project. And in this part of our course, we are going to talk about how to analyze the comments made by our clients, by our customers, with respect to our services, with respect to our product. So it's actually about the intent and not sentiment. Why do we need first to understand the intent and not the sentiment? So let's try to look at this one. So basically, not all our clients, if not 99.9%, actually make short comments. It's actually very scarce, or if not, it is not happening that our client, our customers would give us a very long comments. I think and I believe based on experience, it's not actually happening. With that, it's actually very sometimes very difficult to make an analysis with respect to what does our customer is trying to say, or what aspect of our service of our business do we need to make some improvements based on the comment of our customers, because it's actually very difficult to understand and to identify what and how to improve, as opposed to having very long comments, because we can just actually see it very clearly from the lens of the connecting words, the connecting phrases, and the connecting sentences. In the real world situation, we need to deal with short comments. And that is why we have this kind of lesson. We have this kind of demonstration to show you why do we need to have a logic that would be able to capture the intent and not necessarily sentiment of our client based on short comments. So anyway, why do we need first to understand the intent? Sentiment is actually easier to identify when you have something like this, a very long comments, or when you already have, for example, labeled data. But in cases where when you don't have that labeled data, then it's always very important to have automation on how to tag each comment. So we have here our example. I have actually prepared this one ahead of time. So first, we are going to just run all of these, because when we are in this part, it's actually very long and it may take some minutes for this to be able to be processed and done. So let's first execute this one. So let's restart kernel and run all cells. Restart. Okay. Basically, the first thing that you're going to do is to pip install all of these things. That is, if you don't have yet these different packages in your environment, then you need to. And then after that, you're going to import these packages. And of course, you're going to then download this one, the stop words, and there's the Pong tab. And you may also have to download this one, because this is actually very necessary for Spacey to work in our model. First thing is we're going now to load the data. So it depends on what kind of data, for example, you have. You could have, or you may have just text. You may have Excel, you may have JSON file, but in my case, I only have CSV. Then just to have an overview of what the data is, then I just use a df.head. So I just have the first two entries. Then we first have to understand what the data is all about. So understanding is we would be able first to identify the number of rows, the number of entries, the number of columns, the number of null values. So that's how important knowing all of these things are. And then after that, when we see that nothing is really wrong, so we can continue. So in this case, actually, we have a very good data, because this is just from Kaggle. So it's expected that this one is actually a good data. But in some cases, when you are in the real world, in most cases, you really have to have a lot of things to be done before you go to the data preparation. So understanding the data may take some hours, if not some days, to do it. So data preparation, we have here a lot of steps involved. So first, we're going to remove the unnecessary characters. So we have these characters to be removed. So we first have to ensure that the text is a string. And then this one ensures that HTML tags are removed. And then the second one ensures that non-alphanumeric characters are removed. And also the extra spaces and the strip, leading or trailing spaces are also removed. And then what we do here is we apply this function to our data frame, especially the column review. So as you can see here, and now we have a new column that is named as clean text. We apply the tokenization. So this function defines the process of tokenization and how it is applied to our data frame. So first, to ensure that the text is a string, then we tokenize it, and then this one is just an exception catch. And then we apply this one to the whole column, which is the clean text. Now, we're going to normalize the data. And how do we do that? Let's always remind ourselves that this kind of data is a text data. And in a text data, we can always have a big characters and we also have small characters. And for us to normalize it, we first have to remove the punctuations and then first we have to convert these into lower cases and we have to make sure that it must be in a string format. And then after that, we remove the punctuation. And again, this is just to ensure that removing extra spaces and leading and trailing spaces are properly observed. Now we have a new column that is normalized text, and then we apply that or this function to our whole data, which is the result of the tokenization, and then we have a new column normalized text. Then we remove stop words. So I believe you already know what a stop word is. And for some of you who are watching, you can just actually search the internet and study what stop words are. So again, we need to ensure that the text is a string. Then after that, we are going now to filter the words. So word for word in words if word that lower, not in stop words. Now we're going to join the filtered words back into a string, right? And then we apply the whole or this function to the data frame. And to be more specific, it's the normalized text column. And then we now have a new data frame. But first and foremost, we first have to drop the null values. So this is very important for us to make it sure that we do not process a row that contain null values or it does not have anything. So that should be removed. So this is our new data frame. So as you could see here, we have a new column for each step. We have the clean text. Now we have the tokenized text. The clean text is just removing those characters that are not important, even the extra spaces and the trading spaces. And then we normalize the text by making sure that all text, all characters, of course, except numbers, all characters are in their lower cases. And then we remove the stop words. And then we just have to make sure that we don't really have now null values in our data frame because prior to this, we do this process. We remove those rows that have missing values. So we have now here our new data frame having 6 columns, 2 original and 4 extra columns. So this one now is the heart of what we're talking here. So basically, the most important thing here is we have to load the large English NLP model. So this contain the words that are needed for us to be able to recognize, identify, and to make some kind of association and calculation of a similarity between and among words. Basically, this NCOREB LT, or language, contain all those things that we need. So here, first, we define the most common words. So we list what these common words are in our data. And then here is just a computation of the lexical similarity between the words or even among the words. And then we just compute the ratio to make sure that the result is just between 0 and 1. Now, after that, we extract the labels. And how do we do that? We first concatenate, and then we get those most common words. And these common words must be verbs, objects, nouns in our given document or in our document. So these are just the content words. So we process each document and then we extract these things. Here, we take the most common words for verbs, direct objects, and nouns, and so on and so forth. And of course, we remove the empty strings, add labels to our set, is to find the closest existing label if the limit is reached. So what is this limit? So our limit here is 5. So we've set our labels to 5. So we can actually have 10, we can actually have 15. But if you're going to ask me, what would be the basis of our setting? So the basis here is our business need. So it's always very important to talk to the business people or to the one who has the mastery with respect to the domain understanding of what this business is all about. And now, because we've set that into only 5, so let's see what this data frame now is all about, because we have added a new category. So our new category now is here. So we in Fazan 453 and so on and so forth. And now let's see what these new categories are. So value count. So we have VPN, dialogue, we have the region connection, dialogue product, and so on and so forth. So maybe so now you would want to ask me, is this the final one? So of course, this one is not the final one. So first have to assess, does this one give more essence or more understanding, or is this one logical? So if this one is logical, then of course this method is doing its real work. But as far as the new category is concerned, then you may have to make some adjustments with respect to the name. So for example, you have here ESA number connection. So this may talk something about the connection. For this one, the dialogue product, it can be all about the product features. And this one, the region, this because this one is actually the name of a person. So we have the region. It can be that this talks about the different locations or different places where your customers live, and that they may have different sentiment or intents.
Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like machine learning essentials, deep learning mathematics, and a lot more. Here, you can always learn an upskill for free.